By the 17th century, the Enlightenment or Renaissance was taking root across Europe, and the emergence in astronomy from the dark days of the geocentric universe was being replaced with the heliocentric universe, first introduced by Nicholas Copernicus, then shown geometrically by Johannes Kepler, and then finally proven observationally by Galileo. A young scholar by the name of Isaac Newton in England at the time was studying natural philosophy at the University of Cambridge. And he spent much of his time thinking about motion. And in order to discuss Isaac Newton's laws of motion, let's just clarify a few common terms associated with motion. So here we have a car, it's going down the highway. If we say that the car has a specific speed, let's say 60 miles per hour, that's the same thing as saying that it's covering some distance over an amount of time. But the velocity, on the other hand, is a little bit different. It's speed combined with a direction. So 60 miles per hour northbound. However you want to define that direction, you've got to include some direction component to convert speed into velocity. Likewise, acceleration is just a change in velocity. So we can imagine ourselves pressing down on the accelerator pedal. That'll increase our speed, therefore we've accelerated. But we can also do the same thing just by slowing down. We're decreasing our speed, so technically that's a form of acceleration as well. Finally, we can even change our velocity, or rather we can accelerate by keeping our speed the same, but just turning the steering wheel, just making a turn left or right while keeping the speed the same is acceleration as well. Why? Because acceleration is a change in velocity, and velocity is simply speed combined with the direction. So this brings us to Newton's first law of motion. It states that any object that is at rest or is in a state of continuous motion is going to remain that way unless some force acts upon it. So this is often called the law of inertia. So in this image, we have the Apollo 14 service and command module. And you notice that there's a rocket engine on the back of the spacecraft and it's not burning. And yet the spacecraft is heading along its way toward the moon. The reason for this is because inertia. Once the spaceship got up to speed, the rocket engine cut off and it was allowed to coast all the way to the moon. If it were to miss the moon, it would continue to coast and keep on coasting, and nothing would stop it unless there was some kind of a force that would act upon it. But the second law states that an acceleration on a body is proportional to and in the direction of the force acting upon it. We often write that mathematically as force is the product of mass times acceleration. If you like, you could turn it around and say that acceleration is the same thing as the force divided by a mass. So here we have an astronaut holding in her hand a telephone booth-sized instrument that was going to be installed on the Hubble Space Telescope. It's very heavy, that is to say it's very massive, and in order for her to move it, she has to exert some kind of a force. So if you take a look at that second equation at the bottom, we have acceleration is equal to the force divided by the mass. If the mass is very, very large, then the force needs to be rather large in order to generate an acceleration. Likewise, if the mass is very small, then a small force is all that is needed to achieve the same acceleration. Newton's third law is often misstated as for every action there's an equal and opposite reaction, but it's more accurately stated as a result of forces. So for every force, there is always an equal reaction force, but it's in the opposite direction. So here we have SpaceX's Falcon Heavy rocket on its inaugural flight. As it flies off the launch pad, it throws fuel out the back end. The rocket exhausts fuel in one direction, and the fuel pushes back on the rocket in the opposite direction with the exact same amount of force. This causes the rocket to accelerate. We learned that from Newton's second law, right? If you have a mass, the rocket has a mass, you give it a force, it accelerates. Well, you throw the fuel out the back, the fuel pushes back on you, and therefore you accelerate in the opposite direction. So those are Newton's three laws of motion, and we're now going to show how they apply to create things like gravity.